run short. I'm expecting routing cap, GRE, and mobile throughput guidance to each need half an hour, and so I think we're going to use all two. But I'm optimistic Joe's will run short. Okay. I saw the email. Did you understand the context? We've got the enterprise SCTF API extension to work on.
We need to write the section that says the extension, so we put it in IETF, so they don't get discussed why do the TCP.
Oh, do we have to write for them, or
we will get some authors, and we'll say this is okay, and then the shepherd writer will say TF
okay, and the email is we round up some willing volunteers right to so that graph goes.
But we know we did.
Yeah, we did always right. Yeah, we do. Unfortunately. Yes. Yeah, but it comes, that's why we're doing the virtual bit. Right. When it comes to that protocol, we have likely suspects, and we know who they are. Exactly.
Which actually works. So I'm pleased.
Yeah, I am too. Okay. So let me go put this thing in the statement.
What else we got here? That's strange. Yeah, we got.
Okay, appears to work. Good.
Yeah, that's fine.
All right, ready?
You have a note taking.
Okay. I need a volunteer to take notes, please. This is real simple. We just want summaries. We'll even try from up front here to tell you what to note down from the Q&A. I don't need every speaker's name what they said, please. Can I get a volunteer to take notes for us? All right.
Okay, try speaking.
Okay, so Tim, can you take notes for us?
Okay, Andrew, can you take notes for us? Okay, that works.
Let's see if we can round up one more person. Thank you, Fred.
So, note takers, Andrew McGregor, Fred Baker.
Okay, thank you. Should we give them stars too?
I don't know whether we're allowed to.
Okay. All right.
Be permissive in what you give out as favor.
Okay, all right. If our note takers would like a little coloured star, if you feel rewarded by this, then you can have one. Okay, on to the sensible stuff. We have an interesting agenda for this and the next meeting. Before we say more, it's time to reveal our magic note well slide.
There it is.
If you haven't seen this before, read it. If you have, then adhere to it, please.
Okay, we've got a note taker, we've got a scribe. Reminder, please put TSVWG as the second word or whatever the heck it is in the file name when you submit a draft. That way we might notice. Administrivia. James Polk has stepped down as a working group chair. We and the area directors thank him for his long years of dedicated service to TSVWG in the transport area. However, working group's activity has not stepped down. Therefore, we are looking for a third working group chair. If you're interested, please talk to the chairs. That would be Gory and David, and the ADs, Spencer and Martin, who just ducked. Let the record show he ducked.
Or you can just walk around passing out stars. What the jammer scribe.
We're trying to be more sensible than that. If we can't get a new working group chair, we'd be interested in a working group secretary. So if you're interested at all in helping in any way, let us know.
Okay, so this time around we have some accomplishments to report. RSVP support for PCN finally staggered into the RFC editor, and they made prompt work of it, and it came out. So we now have RFC 7417. Congratulations to the authors, and thank you very much for your patience. This took a while. Since we got one out, we figured we'd do well, so we put two in. There are two SCTP drafts in the RFC editor queue. We almost had a third one make it there. The port use draft is almost done. We really truly hope you'll see why in about 5 minutes when we put the slides up for it. But that one's close. We have one internet draft last call going to ISG soon, SCTP failover. This is on the Thursday agenda. We've got a little bit of work to do on it, but we expect it out of here. So expect it on its way to the ADs and ISG soon. No IDs in Workgroup Last Call, but we have two that are likely to go to Workgroup Last Call soon. UDP Usage Guidelines Update. And this last call may take a while, because this is 5405 BIS. And 5405 is a rather important transport doc. A lot of people care about it. We may be recruiting ringers to go look at this last call in the hopes of heading off IETF last call issues. In addition, the SCP and data chunk, which I'm still looking for a better name, is likely to go with last call shortly after Dallas as well.
Interesting note, we submitted 2 IDs. If we succeed, we might get 4 IDs to our AD. So we did 1, 2, 4. Anyone guess what we'll do next time?
No, the sequence doesn't continue quite that way. Okay. We can try. We have 7 remaining IDs. They're listed here. I'm not going to read them. We have a couple of expired RSVP IDs. We will see if there's any interest in working on those. If not, we'll talk to the ADs about what happens. 2 related IDs remind people of explicit congestion notification benefits and pitfalls over in the AQM working group, and the DiffServ and real-time communication draft, which came out of the DART working group, now concluded, and that one's in the RFC editor queue. That was a joint transport and RI effort. All right, agenda. We get to bash it. Note well, you've seen it. We've just done document accomplishments and status. Milestone reviews coming up next, drafts. Thursday, note well, another round of drafts. One of the things you probably noticed is every time we have 2 TSUWG sessions, all the SCTP stuff seems to clump together in one of them. I have no idea how that happens. This time around, SCTP is Thursday. Okay, milestones, and then we'll go bash the agenda. Okay, so looking at the not done ones. The January 2014 is, that isn't going to work. January 2014 is inspired RSVP draft. The 3 November 2014 milestones are going to be updated. Those drafts were missing in Action Honolulu. They're back. The 2 SCTP NAT drafts are merged. They're probably going to get milestones late this year. I'm going to guess we're going to put them in December and figure out whether we can get that many drafts done in December or not. April is another missing RSVP draft. Then we have the 2 SCTP drafts that we think will get done in May. DSCP packet runs for RTC Web is scheduled for August. We have the guidelines for adding condition notification to IP encapsulating protocols, August. 4 more drafts in December. UDP usage guidelines is scheduled for December. It's the last one on the slide here. We're going to try to send it to last call in the hope of getting it done. We always get many of these good graces when we beat the milestones, because occasionally we don't. Okay. IDs calling Google adoption, none at this meeting. We have adopted 2 new workgroup IDs since the last meeting. We have 10 active workgroup drafts plus support use draft, enough to keep us all busy for a while. All right, here's the agenda. It's been bashed several times over, and there's one more bash on the next slide. So today, item 1, document status, chart and accomplishments. Item 2, transport port uses. This is going to be your chairs with an update from IESG evaluation, and we've got a crucial piece of text that we need to get some working agreement on. Then the routing area has working on encapsulation considerations. In case you haven't noticed, there's a bunch of people who are trying to run the whole internet over UDP. A number of them are in the routing area. Eric Nordmark is going to be here to talk to us about transport considerations in the work they're doing designing new encapsulation and routing, followed by another piece of running your network over UDP, GRE and UDP draft, a mobile throughput guidance exposure, which is an individual draft. This is expected to be a requirements discussion about goals and possible new work. If time permits, we'll take up the UDP usage draft on Thursday. I have no idea whether time's going to permit. Let me show you the Thursday agenda, then we can go bash it. Thursday agenda has been pre-bashed. Everything else is landing here. We're going to start with a quick summary of what we need to do. Item 6.1 is brand new. We have an SCTP socket API work item that's landed over here as a consequence of some work being done in TCPM. Should be able to figure out what to do it fairly quickly. UDP usage guidelines, SCTP end data chunk, SCTP failover, diff serve intercon classes, network transport circuit breakers, congestion notification guidelines, additions. An internal congestion feedback draft, that one we're going to have a discussion on what we're going to do about. This is still an individual draft. There's been some traffic on the mailing list. We're going to try to figure out what the way forward is. If time permits, there's another proposed new SCTP work item that Michael will tell us about if we get to it. Anybody want to bash the agenda? Consider it bashed. Okay. So, now, port use. Go, you want to talk? I'll flip 7.4. It's my tar, baby.
That's fine. Hi, I'm Gary Fairhurst. I'm not Joe Touch. I like doing this. Here's some recommendations on using assigned transport port numbers. This draft's been through working group last call. It's currently still with the IESG. They're discussing various issues. If you want to check the tracker, they've discussed a lot of issues, and there are a few left to finish. Next slide.
Yeah, we're actually quite well on the tracker. I think we had total 6 discussions when we started. We're down to 2.
Yeah, we are making significant headway with this. The purpose of the document is a BCP advice to protocol designers. This comes primarily from experience with the IANA ports review team. These are the people who get the requests for people wanting to write new protocols and needing port numbers. But then people have to explain how they use those port numbers, and some of that expertise comes from this working group, which tells people how to make good applications using ports. One of the basic underlying premises is to make sure that people understand the idea of port conservation. Ports are not running out. If we don't manage them well, they will run out. We want to encourage the use of existing services, don't reinvent the wheel, and clarify how to describe a service in an application or an ID. It's not intended as directions to the IESG, although they are reading it carefully, so it's good that they're reading it so carefully. But it's not direction to the IESG, nor is it really expert review team guidance. There's a separate document that provides this guidance. It's a thing that people can be pointed at just to understand where they have to justify things, what is considered normal, and therefore whether their request is something out of the norm.
Right, and in particular, one of the odd things about this draft, I should say unusual, is you folks in the room are not its intended audience. Its intended audience is people who aren't familiar with the ways of IETF, who design protocols and are going to ask for ports. This is guidance about how to write how to design a protocol and put the application for a port number together in a fashion that makes it much more likely to be approved in a reasonably expeditious fashion.
So, the IESG got this, and they read it, and they read it in detail, and I think they now understand a lot about why it was written, because they've asked lots of questions, which has made the document slightly better. We've been through several iterations. We've used a Rev 08, with some fairly substantial changes to make things clearer, and I think all that was really good, so the process is working well. Then there's a 09, which you see next slide. I mean, you can look at these. These are published drafts Oh, we have a comment at the mic.
Oh, I have a question. At what point do we reinvent? Oh, I'm sorry, Fred Baker, random router vendor. We only do random routers. But at what point do we rebuild Courier so that we don't have this problem?
Do we rebuild
Courier? XNS Internet Transport. What you would do is come into SBP with basically a random source port and destination port 0. It would set up fire off a thread or a process or whatever, assign it a port, and it would come back. You now have a random source and destination port. That's where ASN1 came from. That's another discussion. But at what point do we reinvent Courier and not have this problem of static ports?
Well, Fred, there you go. That's not what this draft's about. This draft is about the exact opposite query, which is several people have noted port requests for more than 1,000 ports for the same application, because they thought they might need that many, perhaps. If you have a single port and you can do a rendezvous protocol of any sort, that's great. If you could do something in more magic, then maybe that's fun. We shouldn't be opening a new can of worms at this moment. We're trying to finish this piece of work and get it through the IESG. So we are working on the final version, hopefully, of this.
Yeah. And to follow up a little bit on the question Fred thought he asked and maybe didn't mean to, at current rate of port assignment, we've got something like 80 years ahead of us. We're in very good shape because of the diligence of the port review team, or to quote one of our ADs, silly rabbit. The reason we don't have a running out of ports crisis is because the port review team has been diligently conserving ports.
8 years to become 40 years, did we double the allocation rate, yes? Not going there. There were some important changes in wording which you may have noticed, which probably were important. We changed the title and the abstract. We focused on the assigned ports, not all ports, and we did various other clarifications. A lot of the remaining stuff to be done centers on security issues. How many ports you should use to be secure is an interesting question, and having looked around personally among the RFCs and advice that we've published, I didn't find a lot of advice really on this published in the RFC series. So we end up having to distill what we can. Should we just move on to the next slide?
Yeah, okay. Here comes the dirty laundry.
What do we say about security here? Well, we could say more, so that's good. We could describe DTLS, TCP/AO, I don't know who wrote that, IPsec. We had a problem with how many ports is normal for security. Is it 1? Is it 2? If you have a protocol that has a secure version, should use a separate port for an insecure version. This point was debated at some length, and view text was written which removed "one must" and changed something to use the word encouragement, which is encouraging. And basically, what we're trying to do here is combine what we regard as security area wisdom in this space with what we call port conservation, which is the general principle for allocating ports, or assigning them as it is appropriately called. Okay. Right, Section 8 has been updated to align with Section 7.4, and we will soon see new text. Before we get there, let's take a question from Scott.
Scott Bradner, just for the edification of the community, what was the conclusion? 1, 2, 43?
I'm sorry, how many ports? Okay, yeah, so I get to explain the point in the stick. The conclusion is that the security area has no general preference for 1 port versus 2. The security answer to, should I use 1 port or 2, is show me your protocol, and there will be a reasonable security view, recommendation, whatnot, but it is protocol specific, and how many ports to use is going to depend on the protocol. In contrast, the port conservation view in general is, if in doubt, 1 port is generally better than 2, but see protocol specifics. And I'm about to put up the exact text we're going to use to do this.
speaking as somebody who actually has to police whether somebody's running secure or not, it's not easy to do with one port.
You can go join the confusion on the SAG list. Have a nice time.
David, if you back off just about that far, that's a really hot mic.
I'm sorry. So Scott, the comment was, it was a little snarky, I apologize. The issue of running secure and the issue of what's the right thing, all things considered, not just running secure, was debated by the security area on the SAG list. And the stated consensus of the weapons security area is lack of consensus at the general scope of question. They will have consensus protocol by protocol, but they cannot offer they are not prepared to offer general security advice on the abstract question.
So the slide says must was changed to encouragement.
Please bear with me. This slide was, I'm about to show you the precise text we're going to use.
Thanks.
Because there are two paragraphs that we spent. I don't know that we set a record on number of words in email versus ratio of words email to number of words resulting in text. But boy, did we try. I think we had 6 ADs involved in this one. I'm still here. All my limbs are attached. Okay.
So basically what we're trying to do here is show you the outcome as we see it at the moment of what has been distilled from this discussion and the proposed new text. With the hope that people here will see this and either have no objection or will provide some clear comment which can be used to feed the end part of this process.
Okay.
The text is here. David, do you want to talk about this text specifically?
Okay, so what I have here in the file, it's up on the screen now. I have copied out the entire section 7.4 on security and highlighted the paragraphs that were in effect written by a design team of Joe, Gory, yours truly, and I think 6 ADs. I don't know if it was 6, but it sure felt like half a dozen ADs. Want to quickly explain what is going on in those paragraphs. So, first of all, this second sentence in that first paragraph is the security area's view of the world. There is no consensus when server ports should be used for secure and insecure variants of same service. That's a security statement. The next sentence is the port conservation statement. First, that makes sense in port conservation statement, citing not only Section 6 of this document goes in port conservation, but Section 7.2 of RSC 6335, which records IE consensus, the port conservation value principle, followed by a general exception that says there will be exceptions when 2 ports are assigned, and the port reviewers do assign 2 ports have assigned 2 ports on a regular basis and are prepared to do so when circumstances warrant. However, circumstances need to warrant. Therefore, if you're going to ask for 2 ports, like your high school teacher said, show your work. Explain why you need 2 ports and how the service is running over the 2 ports, secure and insecure, are distinguishable, pointing at some other protocol that's got an insecure port and claiming therefore I need 2 is insufficient, and it will not carry the day.
So, comments on this text. Okay, comment.
Scott Briner. The reason I bring it up is this happens to be a specific problem in my day job today. That we have a situation where the client of a client-server interaction and the server of a client-server interaction have different semantics on requesting secure communication. Happens to be Oracle, in case you might want to know the blame. The client can request but not demand security. The server can demand security but can be easily misconfigured. And we have run across a few very specific, very concrete cases where the client says, I want security, and the server has been configured to not permit it, and nobody knows. There was no error given to the client end. So this is a real and constant, current problem for me, so this is why I'm sensitive to it.
Right. And if that particular protocol were brought to the port review team, that particular explanation, you probably have a good justification for wanting 2 ports, because you have a secure service, you have an insecure service, and you have a strong operational need to distinguish them.
Any more comments? Okay.
Are there any?
Hi, Tom Herbert. So it's not about this, but more generally. So recently I actually applied.
I'm sorry. I hate to do this, but I've had half a dozen of these make my life interesting. I need to get past this text. When I pass this text, you're more than welcome to come to the mic.
So there are 2 things that I'd like to point out. First is, this is the text that we intend to put into this document. So if it doesn't look right, please tell us. The second is a judgment call by me. I don't think this is substantially different to the original text. The words are completely different. The recommendation that you have to provide a justification if you want more than 1 port remains the same. My personal claim is that this does not change what was passed through the working group last call, but it certainly completely rewords it. So please tell us if you have a differing opinion, because this is an important point to get right.
Scott Wagner, it makes 2 contradictory factual statements.
Yes, and so did the original.
Yes.
So it's not anything worse than the original.
Correct.
That's hardly an advertisement.
Well, we
tried hard.
Right.
I would quibble on the first sentence of the second paragraph. When simultaneously requesting a secure and an insecure port assignment for the same service, justification is required for each port. It seems to me like I would focus on justification for having an insecure port at all.
That also is stated somewhere else in the document. Is it?
It is stated elsewhere in the document, and that turned out to be one of the points with a very high heat to light ratio in discussion with the IESG. The text you're quibbling with was finely crafted. I apologize again.
Yeah, so the general recommendation, is use security.
Yes.
And so this is later in the document when we say what happens if you really ask for 2. Okay, any more takers?
Mm-hmm.
John Messenger from ADVA. So it's fine if I apply for 1 port one day and another port the next day. I don't need to make any justification at all, right?
Wrong.
No.
That's what it says.
That's what it says.
Simultaneously. I don't think that's fair.
Why don't you just delete the word simultaneous?
I can see there might be merits to removing the word simultaneously. Can somebody explain? Oh, Martin.
I just want to say that if you're saying, and you just did say, that earlier in the document that you make the statement, the document makes a statement of do it securely or suffer your fees. Why don't you say that here? Why don't you say that the guidance of this document is to have 1 port and that's a secure port? Why don't you just say that? And then go on to say what you say.
Scott, Scott's covering that. First of all, the highlighted text actually says that. The second is that we did try to say that. It was cut to slivers by ADs who I won't name. Martin. No, he was involved.
So it wasn't me. So Martin Stimmel is speaking not as AD, but as a port expert reviewer who is actually getting all those requests. And I think it's probably a good idea to remove the word simultaneously here, because typically if you get like day one request and get like 10 days later the second request, I then I will check for what has happened before, and we get both on the table saying, by the way, they already asked for an insecure version. Just so that makes sense to remove that word.
Okay.
I think Ayanna has a memory.
Yes. I think that's...
Hey, great, so we've actually bashed it and achieved one useful reduction. Seriously, this is in IESG discuss, we will receive more feedback on this text from them, so it may yet have to change, but we're hopeful that this is good text. You can follow this, and if you have opinions, please make sure that they are known while this process is still going on.
Okay, so send the IESG a discuss.
Send the IESG a discuss.
They send us.
That's a clever idea, Fred. You want to see it tomorrow night?
Let's consider this item discussed. The actual process continues, and an RFC is not published until it's published. If there's something wrong, we need to know.
Okay. Are there any objections to the text shown in large, bold font on the screen? Seeing none, the sense of the room is that this text is acceptable to the working group. Thank you. Yes, the word simultaneously will be removed. That's what's going to go forward.
And I think we can hum on that.
All right. You want to call the hums?
Yes. Could you hum if you think this text is acceptable for going into the document? And the second hum will be if you think that there are things that need to be changed or further worked upon in this text. So please hum if you think this text represents a useful piece of text and is okay to include in this discussion. Please hum if you have reservations and you think that the process needs to consider more options.
Would the note takers please record that the second request for hum has met with silence? Yes, I think we're done now. Thank you. Occasionally we got to do this kind of open text surgery here. Thank you very much. All right. Do something more interesting. Yeah, let's go figure out what was next here. Oh, okay. Eric, I think you're up, and somebody needs to drop Aria a note, please. No, I can't do that. Sir? Have you Peter? Thank you. Okay, good. All right, let me go find your slides here. And okay, hang on a minute. Outlook decided to be helpful. Just a minute here. Well, we'll just put its windows in the background and put something far more useful up front. Wait a minute, we're going to encapsulate Outlook. There we go. Hang on a minute here. I got to tell Outlook to get lost. And there we go. Okay. And do this. Full screen mode. Okay.
So, what? Oh, sounds a bit crackling, but so there's a design team here that Alia. Is it sounding good or weird?
Yeah.
Okay. You can go to the next slide. So there's a draft covering this stuff. So there's a design team here that was chartered back in Honolulu, and we have been out on a safari. Are we going on a safari this week? Sorry. It's Albert, me, Jesse, and John, and Larry, and Pankaj, and Pat, and Tom. And basically we pulled together people that were working on different existing NCAPs within the IETF. Yeah, it sounds weird to me, but... Okay, then I don't hear anything. Is that better?
Yeah, it's actually picking up. If you can't hear the feedback, it's probably okay.
Yeah, I can't hear it myself, so okay.
All right.
Okay, I'll do that. Let me know if it gets too quiet. So, the charter is at that link. So next page. So the motivation for this stuff was that the IETF is doing, 3 encapsulations at the same time, 3 new ones. NBO3, that's, if people don't know, is about network virtualization.
the service function chaining, and there is something called bit index replication, a working group that was just chartered. And in general, these encapsulations, there are cases when you would end up using multiple of them in the same packet. Each encapsulation has its own information that it carries, but it also needs to handle some set of common issues because it needs to work on the internet or on IP networks at least of some form. And the design team has been looking at what are the common ways we can do these common issues. And in the sort of sales pitch when I recruited people, or when we recruited people for this design team, was if we do this stuff here, you don't have to go and reinvent your own square wheel, right? We can actually figure out how to handle these common issues and help the people that are working on encapsulations. So next slide. So what this is a look across the 3 different encapsulations while also looking at some of the sort of older previous work that people have been doing with various content protocols. And we decided to focus on sort of encapsulations that are designed to run over UDP and or IP. And this is because of the current ones that we looked at, but also we didn't want to sort of get too entangled with things where there's this close coupling between the control plane and data plane, like for MPLS, for instance. It's not that we think that MPLS is a bad idea, it's more like we can think more clearly about what the data plane means when we're talking about something that runs over UDP or IP. And by the way, there's some red words here. They don't actually mean what you think. That's why I colored them specifically for this room, because you need to have different color glasses. What transport you in the routing area is various planes, right? It's not what you think. So just to make sure everybody's awake and it's not going to react to transport meaning something different. But the meaning on the slides is the same thing on the document. I didn't want to use a different term in the slides in this room than in the slides in the next session. So this means that a result of the work we did was that some of the sort of transport independence here, some of the assumptions about the underlying way the packets get delivered actually fall out. So in MPLS there's a thing called entropy label, and that actually falls out from some of these things. The other thing is, so I'm actually presenting this scheduling-wise as things moved around. So actually the session after this one, that I'm going to present this in the routing working group as well. So. And we have a bunch of the design team members in the room, so you can throw credit to them as well. I mean, credit goes to them as well. So next one. So what this is not trying to come up with some new encapsulation that's sort of better or tries to capture all of these things. It's not trying to have some criteria for selecting encapsulations or selecting them either, right? It's just saying we think that there's a bunch of things that are common that you have to worry about when you define these protocols, and that's what we looked at. Next. So we came up with about 12 issues to go look at. I'm actually going to talk about, after conversing with the chair, said, well, the ones that seem to be most relevant or interesting for transport are actually the ones that are in bold, if you can make the distinction, but it's like half of them. So, next. So, one thing that is important when you think about this, particularly when you think about security, are, even though at some level this is just some set of bits that, from the generic perspective, we don't care about the semantics, right? It could be DNI ID for NVO3, for instance. They have different behavior with respect to on-path modifications. So, for instance, in NVO3, there is some form of DNI ID which is assumed to be carried, end-to-end or from NCAP to DCAP. But there might be some other some other things that people haven't figured out yet that may be modified along the path. Beer at the other end of the scale basically has a bitmap that's modified by every beer router, right, along the path. So, and SFC is a bit sort of in the middle of that. Yeah, there's at least some loop avoidance index in SFC that is modified in every path. And there might be some service metadata that's modified sort of outside of the SFC forwarding itself. So this is important to keep in mind as people think about what it means to secure these protocols on runtime. Next. So some interesting things for transport. So the different groups working on this seem to have come to the conclusion that they can sort of, at a provisioning time, take care of path MTU issues. And this seems to be true both sort of in the data center places where people think about NBO3 and SFC, and also in the service provider cases where people are thinking about beer, that you can basically ensure that the MTU that I offer at the edge, I can take my encapsulation overhead and ensure that my underlay is capable of carrying that size packets. And so I don't have to worry about doing sort of MTU discovery across the tunnel or fragmentation across the tunnel. That might not be true if you took these protocols and deployed them on an arbitrary internet path, right? Then you have to worry about those things. The sort of traffic engineering and traffic management, there's pieces there that might make sense sort of from NCAP to DCAP that are actually quite different from what you might think about from a generic TCP congestion control perspective. That people seem to assume that we have some underlay, similar to the MTU case, that is sort of well provisioned, well managed, but you might still worry about what traffic is actually being injected in here. You know, if I'm running this in a data center and people have multi-tenant, you know, random VMs, well, they don't actually trust whatever TCP stack might be running in there or whatever is sending packets in there. And the other thing is that it's probably useful for people to think about implementation considerations in hardware or software for this stuff, and understanding a bit what that means. Next. So I don't know how much people have seen what currently is being done here, but a lot of the push for doing stuff on top of UDP is because people want to have some entropy in the packets that could be used to leverage underlay ECMP. And that's something that Lisp introduced a long time ago, being able to stick a hash of the inner packet in the UDP source port. So the things that we point out is that, well, you might be able to use 16 bits of this, or you might need to restrict yourself to 14 bits. It depends on whether you think that there's any boxes in your path that actually look at UDP source ports for firewall purposes or anything else, right? That assign semantics to the well-known UDP ports, etc. We've had some discussions around using IPv6 and the fact that IPv6 can actually provide more bits. It's not clear that one would need some more bits sort of in addition to these bits, because we can get more. When you move to IPv6, you get more source and destination IP addresses. And when you move to IPv6, you could also include the flow label and the entropy calculation, so that you have more bits to play with in the future, right? Today you sort of have, you can play with the source and destination IP address. Your tunnel endpoints can have multiple IP addresses if you want, and that you get more and more flexibility as you move forward. The other thing that, as we talked about, particularly in terms of stacking these things, this notion of an entropy field basically belongs to the, I don't know if I should say the word, but, well, I could say the delivery mechanism that you use. It's basically something that, from the perspective of the end caps, you would really have wanted IP to do for you, right? And the fact that you need to slap a UDP header to get those bits there is at some level irrelevant, right? But you view that as part of the delivery, and then if you happen to use MPLS as the other one and it has an entropy label, that's fine. It actually looks the same from the perspective of the encapsulator. And it's actually quite happy that things seem to fit together that well. Nice. There's a couple of places where the encapsulations have to worry about indicating a next header. One is that the encapsulation itself might want to carry different inner payloads. It might be IPv4, IPv6, Ethernet, whatever. or anything else. There's also the case when I have, combinations of these encapsulations, so NVO3 plus SFC, for instance. And then it's all, the third piece is, well, you have to carry this thing in the underlying delivery mechanism, whatever that might be. If the delivery thing is UDP, you need a UDP destination port. But it could be other things as well, like an Ethernet type, if you want to carry it in something else. There's an open question, which is really an IETF question, whether it's, when we do this sort of layering of things, does it make sense to have a common numbering space for these things that's not the Ethernet type field, not the IP protocol field, or sort of share that across these different encapsulations? Or whether it's fine to say they can just define their own, and we know how to deal with that in general. Next. So as I said, one of the assumptions here is that the MTU is well managed, so we don't actually have to do anything, right? Well, it turns out that in real world, you might think that things are well managed, but things are misconfigured. So one of the things we realized that even though you don't have to worry about fragmentation being mandatory for these encapsulations, the way they're planned to be deployed, it's useful to be able to detect when you have some misconfiguration. And we can actually do that stuff by basically setting don't fragment in the outer IP header and just using that as a mechanism to record that, oh, the underlay wanted to fragment this stuff, something is misconfigured, sound the alarm, right? This is something that works well when the protocols, well, you can actually do more, sorry, remember what's in the slide. You can actually do more if you want. It's not clear that it's needed when you're carrying an IPv4 or IPv6 payload, because you can actually detect the path MTU that you see over the tunnel, but some of these NCAPs will carry arbitrary Ethernet types. In that case, you don't have a signaling mechanism to go back to the sender, right? There is some sort of informational LLDP TLDs that can be used to say, this is what the actual MTU is of my Ethernet link, but it's not something that hosts typically care about and do anything with. So if you're trying to generalize this stuff to other encapsulations, well, that are deployed in different environments, it might be quite reasonable to require them to do fragmentation and reassembly. But there seems to be a clause here that people say, partly because they want to implement in hardware, partly because of how they're deployed or intended to be deployed, say, they don't think that that's required.
I'm going to pass along a nugget of wisdom from the IAB semi-workshop. Be careful about that overlay ICMP. If you think the UDP ports are reversible, and somebody nested this encap in another one of these encaps, and the source UDP port is for entropy purposes only, the ICMP that you send back might be getting bit bucketed. In addition, by the time it unwinds its way out of all the tunnels, even if it can go back, you may not have enough information to gen it. And finally, people are getting really, really clever about one-way tunnels, and there is no reverse path, or the reverse path is not here. So it may be possible, but and I think I'm with Bob Briscoe back there, who I think beat us up on this one in Zurich. There are a lot of practical reasons why in configs that aren't just one encap goes from point A to point B, you may not be able to generate the ICMP going back and actually A, generate and B, deliver it.
Yes, that's a good point. Yes.
Could I just kind of add on to that? If you have nested encapsulations within encapsulations within encapsulations, you could consume that available MTU that you carefully configured. So you still may get into a situation.
But I think that's part of these networks being carefully managed, right? People wouldn't do that, right? That's one of the implicit assumptions. But as you go to say, I'm going to use beer wherever, right? As an example for distributing or replicating multicast. Well, would you run beer within beer? Well, that probably doesn't make sense from a deployment perspective, right? There could be cases when people end up, because of growth, You say, oh, I deployed NVO3, it gives me whatever, 4 million, VNIs. Oh, but I ran out because I allocated them. And I now need to run NVO3 inside NVO3.
Oh, no, that's going to happen faster. Test purposes. I guarantee you will see NVO3 in labs. I'll bet there's running code doing it right now with some of the in-caps.
Temple, just one other question. If you're looking at just these 3 use cases, why not look at all potential use cases and have just one, back to your first slide, why not have one encapsulation that takes care of them all?
Well, there's oceans and boiling and whatever, but we wanted to have a scope for the design team that meant that we could deliver something that is hopefully helpful. So, and don't want to
helplessly hopeless.
Just on that point about you say you manage this, so this isn't going to happen. Bob Briscoe, PT. You don't control how many encapsulations have already been done when it arrives at your ingress. That's the point.
No, but I do control that my whatever box, right? Is the ingress router or whatever to this tunnel. It has at layer 2 some MTU.
Yes.
So I know that the packets aren't bigger than that when I receive them.
Yes, that's true.
So that's what saves me, right? And then as long as I manage the underlay that's between there and the decaps, no, I'm not going to run out. Next. QoS. It seems like this is a case when the work was already done quite a while back. It's just flagging to people that if you want to do an encapsulation, you want to look at existing RFCs that define how to carry like the diffserv DSCP bits, whatever, between the outer and the inner headers. And other people might not be aware of this work, so it makes sense to make them aware of it. There is some other things that come in. So there's been talk of having some particular OAM packets, at least in NVO3 and SFC. And as people do that, they presumably want to make sure that they get the same treatment, those OAM frames, as the packets that they might want to sort of measure. So making sure that whatever OAM, however the OAM packets are defined, that they can actually be treated the same. Next. So there's been work in the transport area in the IETF around congestion-related things, recent work. So this is mostly also just pointing out that work that people have figured out sensible ways of doing this stuff as part of the MPLS over UDP, the circuit breaker discussions. There's some other pieces here that sort of point out that you might need to protect against malicious end stations, and sort of figuring out whether you do that purely at sort of an ingress to a tunnel, or whether you want to do some form of control or policing sort of across the tunnel where the endpoint is. And people might want to go look at other work in the space. I mean, I don't have to necessarily tell you guys that, but the people that are working on these encapsulations, that there's some work in terms of fairness with multi-tenancy, like the ideas that Bob has put in some drafts. So it's just pointers for people to go look at. And the higher debate is that, you can't just ignore this stuff, but this is one of those things that say, you don't have to go recreate this stuff. The work has largely been done already, right? You just have to follow the existing pattern. Yes.
No, this, boy, bad noise. So one of the things that's been worrying me for a number of years is that the dogma in this group that congestion control is a requirement is actually flawed, and the actual requirement is something else. I think the correct requirement is that the efficiency under overload is, I should say the good part under overload is monotonic because the efficiency does not drop. This requirement is particularly important for TCP, but it's actually a requirement for applications as well in a whole lot of parts of the system where we can't enforce it. And it's easy to construct applications that exhibit it's easy to construct applications that will participate in congestion collapse even over TCP implementations that are congestion protected. And I don't know if this affects any of the work in progress, but I think we're actually striving towards a goal that's a little bit broken somehow, and I don't have a complete picture of the right answer. I've been thinking about this for a couple of years, and I still don't know what the answer is. But for one thing, it's easy to construct examples of congestion control traffic which behaves as though it's not congestion control.
Yeah, I mean, I can see that you can construct applications that if all the parts of whatever, my disk blocks don't make it in time, I will send them all again, right, over TCP.
Even DNS, which retries the same question, is subject to congestion collapse under high enough load.
And so in terms of the pieces that we looked at the other end of the spectrum, which is these encaps are defined to be able to carry arbitrary Ethernet payload, so we don't actually know whether that is congestion controlled at all, right? And that's the part that also shows up in the MPLS over UDP work.
Okay.
But I agree that there's a bigger piece of it.
And I'll point out that if you look at Eric's slide, you'll find out that it's a nice mix of congestion control and things that we wouldn't consider classic congestion control. Circuit breaker draft, which will be coming up on Thursday, is not classic congestion control. It's something's gone wrong. Pull. Something's gone wrong. How do you pull the plug? And even one place where he said congestion control is congestion control slash policing. It's not necessarily that we need to roll out a congestion control algorithm, but something needs to be done to protect the network against overload.
Hi, Bob Briscoe. Just one to add to that list that David Black, myself, and Yakov Stein have written is IETF PW3 congestion or cons congestion considerations CONG.
Yeah. Which is probably probably over-advertised because it's mostly around how fixed bandwidth TDM service by and large can't cause congestion unless you've really screwed up the network provisioning.
Okay. So we can definitely add that pointer. So next slide. So there's another thing that showed up, and there's actually two pieces to this puzzle. So one is the discussion about UDP zero checksums over IPv6. But there's also sort of the discussion around, do we need some checksum for the actual information that the encapsulation itself carries and cares about? And this is something that people haven't looked at much so far. They've sort of assumed that, CRCs are too. But we definitely have cases where packets can get misdelivered, like if the NVO3 BNID is corrupted due to undetected bit error in memory while it's sitting in some box somewhere, so it's not covered by the CRC, or the BR bitmap that defines which interfaces the packet is delivered to is corrupted. So if one goes to do that, it makes sense to use the regular, sort of pseudo-header approach so that you also cover misdelivery UDP and the port numbers and IP addresses. But the other part, which I'm not covering as part of this slide, is the security piece. That you might instead have some cryptographic checksum on the packet, and if you do that, presumably you don't actually need the sort of basic internet checksum, whatever it would be. Next. So extensibility. So this is an area that I think that we as the IETF don't actually have a clue about. Because we write these beautiful documents depicted up on top that we think that can be used for great things in the future. But the result is more like the rubber band on the bottom, right? Which is like, okay, but people wanted to use IPv4 options to do extensions. It turned out that hardware sent those things to slope path, and they weren't actually useful at all, right? And when people define IPv6 extension headers, the assumption was that, this would be a flexible way of extending things. Well, it turned out that the middle boxes, it wasn't the routers now it was the middle boxes that said, we don't know how to deal with that stuff, so we'll just throw them away or whatever. right? So we don't have a good track record of figuring out how can we actually define usable extensibility, in particular as people start to do sort of efficient implementations of this in hardware. But we need something so that people can at least introduce incompatible versions, have things that are sort of, if you don't implement it, doesn't matter, the egress can ignore it, and some sort of, you need to drop this stuff because this is some new feature that's sort of mandatory, quote unquote. And we also need to think about that in reality, we will continue to have various on-path devices, whether we like them or not. Some of them we like, some of them we don't, right? That will at least need to be able to parse this thing in a sensible way. People might call those routers in some cases, people might call them middle boxes, right? But thinking about extensibility from the set of sort of devices that we've repeatedly seen come into play that need to be able to know about the stuff. We've talked some about, in the design team, about different encodings, about what makes sense to do here, but I think one of the sort of, and there's some more material in that in the document, but there is, at some level, a notion that if you're going to define these things, you have to figure out how to use the extensibility mechanism from day one. If it's sort of this thing that sits off in a corner, then I think it risks falling in the case that when you go to use it, you'll find that it's not that usable, not usable at all. Right? Next. The design team talked about, what are the cases when we would have multiple combinations here. I think that there's at least one that's relatively well understood, which is an NVO3 plus SFC1. One could add some multicast to that mix if you believe that multicast will show up in the same place. And as we mentioned earlier, that there might be cases when you end up with NVO3 over NVO3 because, well, people want to test it, or they ran out of whatever, 24, 32 bits, whatever NVO3 might have, right? And one question specifically that the design team was asked to go look at is, but would we end up with multiple UDP headers in that case? And I think the short answer is yes, because we view the UDP header as being part of the delivery header. So if it turns out that to do this nested encapsulation, you would have multiple IP headers, you would also have a UDP header to go with each one of them because you've defined your endcap to use the UDP source port for entropy.
So a side comment on that, in a data center the answer is definitely, because quite often VXLAN is in use and that has a UDP header.
Yes.
So your thing becomes VXLAN plus beer plus NVO3 plus beer plus NVO3 plus.
You have use for jumper frames, yes. There are some sort of thoughts on do we place constraints on how people actually interact with these headers when we have layering? And I don't know if I can correctly render it on the slide, but the notion that you can have things that can inspect parse things, but I think that if you're thinking about devices that modify things that are basically intended to be on path for some particular layer, yeah, they would do that in their layer. But if they want to do something else, you have to, in essence, make those devices be visible, right? From an architectural perspective, they would do an NCAP and an DCAP. The same way as an IP router routing between two Ethernets, well, it actually ends up modifying, the implementation ends up modifying the Ethernet header. But that's not how you architecturally describe it. You describe it as DCAP, route the packet, put a new Ethernet header on there, right? Hardware isn't built that way at all. But sort of thinking about architectural things there to make sure that we're not creating, or we're not encouraging sort of strange combinations here. Thanks. So one thing that we sort of touched upon a couple of different places is middle boxes, and I think that one of my realizations is that whether we like them or not, some of them we do, some of them we don't, we're going to see some of these things in place, right? And I think there's cases where we might see something fairly soon in terms of, for all I know, they might already exist, right? Things that in NVO3 land that look at the DNI ID to form some form of firewalling functionality. I know that these set of virtual networks are only supposed to be in that part of the data center, right? And the sort of, does it make sense, and again, and I have a question for the IETF, does it make sense for the IETF to sort of document some sort of constraints in this space, sort of some pitfalls for people to avoid? Because, and we've been around this thing, general topic a number of times with NAPs and whatever, right? What is our role to this? Do we just label these things as evil and try to ignore them and say that they shouldn't exist? Or do we say that, no, can we provide some useful advice here that make it easier? And I think my take is that we should figure out a way to do that because we want extensibility. We want to have a way of evolving our protocols, and sometimes these things get in the way. Right? So how to figure out to do that stuff, that's a separate issue. Next. So there's some other things that I didn't talk much about OAM, but there's some other sort of questions here about these encapsulations might want to have an error reporting protocol in similar ways that IP came with ICMP, right? Is it useful to think about that, or should we just let them figure it out themselves, right? And it might actually turn into, or have similarities with some of the things that people are talking about at the application level as well, with sort of how do I do error reporting from the past, whatever. I mentioned the next protocol in what's it called, indication. There's another piece which is, we've sort of talked about extensibility, what an NCAP would need to support to do some extensibility in the OAM space, and sort of concluded that in that space it might be useful if you could sort of add some options that have sequence numbers, timestamps, whatever. It allows you to do measurements on the encapsulated data traffic as it goes through the network. And that seems to be a useful feature that you can add as an option to an encapsulation. So now you can measure it, right? But we also said, well, there could be other sort of services that you want, and one of the services, the sort of pseudo-wire notions of services like in-order delivery or whatever, right? Well, and we said that, oh, but that would make sense as a layer that's separate from the actual NCAP. Don't try to bake it in there. But in fact, they more or less need the same bits in the header to do this, right? Some sequence numbers and timestamps can be used to implement what's it called, a pseudo-wire type functionality. So it's not clear whether there's any sort of advice coming out of this other than an observation that, you know, if you have this extensibility, people might use it to do things that you wouldn't necessarily think about being part of the NCAP when you start, right? And just see what happens. Next. So, that's it. Any other questions, comments? I'll try to cover all of these issues in the next session, but I'll probably be lighter on the transport things, given that we talked about them.
Martin Stimmerling speaking as one of the transport things. Thanks for this activity that it's there, documenting things. The question I have is that you said at some point that the implicit assumption is that this is running in a well-controlled, managed environment. But there's no explicit mention of this.
I mean, in the different encapsulations?
Well,
the underlay.
Primarily in this document.
The underlay, Eric.
Well, no, I think that text does exist in the document as well in some form.
Okay, well, because let's say from my experience that many of those encapsulations don't state that explicitly, and I would encourage you that in your document you say, like, if you ever work on an encapsulation scheme, you should be stating that if this is intended to be running on the public internet,
yes,
or if it's just confined to, let's say, well-managed, controlled, closed environment, because that makes a huge difference in when the 80s are going to read this in the end, and judging on the congestion control stick out of the box, or we just say, like, okay, in that environment it makes sense.
Yes, I think that's good things, and we should make that more clear.
So Gary first, you may have mentioned it, and I may have missed it, but did you talk about protection from off-path data insertion?
Yeah, so I didn't cover the security topics here, so.
It's kind of like a transporty thing as well with the DDoS type injection. Yeah, you're going to talk about that.
Yes, so there is some material here to talk about off-path attackers, sort of packet injection type things. So there's this, if you're not going to be in the next session, there's actually a few slides on it for the routing working group. you'll recognize most of the slides. I think there's more of them.
Now he's got the audience warmed up.
Spencer Dawkins. Could I ask you back up? I think it's one slide. Yeah. So a question I'm curious about, and then a question somebody may be curious about someday. When we're talking about the center wire type services here and things like that, this also kind of interacts with the discussions we've had about circuit breaker and things like that, doesn't it? That if you had sequence numbers, things like that, it would be easier to tell what was going on than it is today. So I think this is important for more than just the single wire type services. I think it's more broadly important.
Okay, yeah, that's a good observation, but I think at least the way it sort of came up in the OEM context was this would be an optional thing that you would enable because, the customer complained and I turned it on, or I need to keep an eye because I have some SLAs or whatever, right? So it wouldn't be on everywhere all the time.
Sure.
And if you want to use it for circuit breakers, you might want to say, no, I need it there all the time in case something goes wrong.
Right, and I see that you're solving a different problem that we're solving in the circuit breaker conversation, but I'm sorry, go ahead.
Can we just follow up on the circuit breaker? I mean, the circuit breaker doesn't have to actually have sequence numbers to be able to count how many packets you sent versus how many packets you received. I mean, you could use an OEM type cell that kind of just captures what was on the wire for the last period of time, and you would know that for certain. So there are little things you could add that will let you do that automatically.
Yeah.
Yeah, and that actually came up in the NVO3 discussion as well, right? The notion of having some marker, a single bit marker might be sufficient to do some counting and compare counters.
Yeah, and believe me, I don't think I can design this standing here, so I defer to the people that are smart about that. I'm sorry, I have another question, but it's a bar type question. We'll talk later.
Okay. And what I was going to comment on is what is the chunk of functionality a circuit breaker could use is the ability to send a small amount of information so that the ingress and the egress can figure out that what's going in is quite a bit larger than what's coming out, and therefore something might be wrong. So it doesn't need to be sequence numbers, but it does need to be a way to show to get just a little information from the ingress to the egress, or vice versa, so they can figure out that they're not looking at the same thing.
Just to point people at the feedback I've just done on a review of the tunnel congestion feedback thing, which covers that point quite a bit about moving things and deciding where to put it and all that.
So another thing that wasn't on the slides was, so one of the things we have to figure out is sort of what's the home for the document, but also what's the strength of its recommendations. So right now it's mostly in the form of here are things to consider. And I think that's something that we have to figure out as we move forward, whether this document would have that or whether it would point to other documents saying, here's where all the requirements are for doing X, Y, Z.
So how do we help you? I mean, there's lots of people here who know about sort of things on this slide, so it's interesting. What happens next?
So read the document, provide comments on the document. I think that would be step one, right? And then we will see where it goes. And I think the other thing that might be useful in this space is also ensuring that we have enough sort of cross-pollination between the transport area and the routing area for this, right?
Yeah, and on that point, I'm going to channel Leon point out that the primary discussion forum for this is the routing area working group, RTGWG.
Thank you. Come back and tell us what happens next.
You go hide these.
So next talk will be GRE in UDP, where we come to talk about one of the encapsulations we're trying to grow.
Okay. The This is meant to be interactive, by all means. Hopefully this is not a surprise, Tom, but by all means, go ahead and ask questions. You're looking at a draft that's a work in progress.
Okay, they can ask questions, hopefully we can have answers. My name is Tom Herbert, and I'll be representing the GRE over UDP authors today. Actually, Eric's presentation is a great segue into this. This ends up being a practical application of routing or encapsulation. So hopefully we considered most of the areas Eric talked about. So progress since Hawaii, MPLS over UDP draft, complete, headed to RC publication, and we actually took a lot of basically a lot of the text even from that draft and applied it to GRE over UDP, particularly in the areas of checksum and congestion control. And we also, since the last version, updated various topics, so congestion, UDP zero checksums, and ID6 security, source port, and there were some editorial changes also.
Okay, before I go to the next slide, let me go ahead and set a little bit of context here. Tom's pretty much said it. A lot of the text here has been picked up from MPLS over UDP. MPLS and GRE are not the same protocol. Please, as we go through this, think about differences and think about where stuff that we, and I was involved in helping this author team, have taken from MPLS. But it's at best a starting point, and something different or extended or modified is needed because it's GRE over UDP instead of MPLS over UDP.
Yeah, I think one of the differences we kind of anticipated was the scope or the range of GRE over UDP is probably larger than MPLS over UDP. So that's one of the things we consider. So congestion considerations. If the traffic is already congestion controlled, obviously not a problem.
Okay, that's probably me.
How's that?
That's probably me, not him.
Okay.
That's almost certainly me leaning into this one. Sorry. It was me. Yeah. All right.
Is that better?
It's probably me. Tom.
Just talk, Tom, we'll fix David.
Yes, exactly. Go ahead.
Okay. And also we basically fall back on the assumption that IP traffic is assumed to be congestion controlled. The other case that GRE doesn't allow is non-IP traffic, not necessarily congestion controlled, or maybe not known to be congestion controlled. And in this case, the recourse typically would be careful provisioning by a network operator. And it's very important that uncontrolled traffic in that case does not escape to the internet. So we really do not anticipate that this use case of non-congestion controlled traffic over GRE, over UDP, should be escaping or be used on the general internet.
So going first, I come to the mic as an individual, rather than sitting over there. But GRE, I would say most GRE usage is actually not in this context. So, I mean, like when I use a VPN, I always use GRE. So I'm using GRE all over the place with different, either GRE or enhanced GRE to move packets to my home networks. So saying to my service provider that this goes means we really do have to get the scoping right. And I wonder whether the group is clear what we're actually trying to solve. I mean, are we trying to make GRE work over UDP generally, or are we trying to target a very specific application?
Is your VPN traffic, what you're sending over it, congestion controlled?
Depends on whether I'm sending Ethernet frames at layer 2 or whether I'm sending IP packets at layer 3.
What does your VPN provider think you're sending?
And my VPN provider is my own machine at the other end. So there you go.
All right. Okay.
Yeah, I have one of these famous routers that people buy, and it supports both. But I mean, it's not necessarily my problem here. I'm just asking more generally for the group, just to try and tease out where are we trying to use this GRE? Are we trying to be nice to the community and give them another protocol stack because we think we can apply a few more cycles and people here are interested enough to help and make this actually work for practically every application we have with GRE and we can just push it up the stack, or are we not able to do that, and are we honing in on a particular application space?
So I think the dilemma we're facing here is we already have a large deployment of GRE, which, as you point out, probably in most cases as IP or IPv6, Ethernet carrying IP, what have you. There are going to be use cases when it's non-IP. It can carry any ether type. But when we put this over UDP, it's actually, in a sense, enabling a broader extent of the protocol. So places where GRE could not go, it's much more likely that GRE UDP could go. So our exposure is kind of increased. And I think what we're trying to do here is not quantify, but qualify what the effect of that exposure is. So we're hoping most traffic is going to be case A. But we have to have an answer for case B, where we say you cannot run non-IP over GRE over UDP. And maybe that would be an option, but that seems awfully restrictive somehow. So I'm not sure how this matches with the use case. Use case probably is it's mostly congestion controlled anyway, but for completeness, I'm not sure that would be a sufficient answer.
Yeah, it comes back again when you say we're going to turn off the checksum, and then I say, well, I want to use it on my home network. So my home network has a NAT, which actually is quite vintage. I doubt it supports IPv6 packets with a 0 in, but I mean, maybe it does.
So we'll get to the checksum in a minute.
Yeah, exactly. So time to come away from this, Mike, but group as a whole, we kind of have to figure out what we're trying to use this for. I think that's the only thing I'm standing here saying. And so, as we go through the slides, let's look to see why we're doing this work, how we see it used, and therefore help Tom.
Okay, so the technical use case is we want GR over UDP for the benefits of going through networks, ECMP, what have you. So that's the purpose. Now, the use cases, I would claim anything we're doing over GRE today, we should be able to do over GR over UDP. If we wanted to narrow the use cases further, I guess we could, but I'm not sure how that would impact what we write here.
I'll stop stalling your talk. Please carry on.
Brett Temple-Bowen, if you don't mind a quick one. So what's the reason for doing this as opposed to using GRE within GUE encapsulation? Is it just simply to avoid 4 bytes of extra header?
Within another encapsulation protocol?
Using GUE to carry a GRE.
I think this is one of N types of encapsulations. So again, GRE is probably one of the most deployed encapsulations. Actually, we will be talking about various encapsulations, as Eric pointed out. These are going to be more defined. This is one case, hopefully the simplest case. So in answer to your question, I think that's a perfectly valid alternative, and hopefully people will use that. But I think there's merit here, and currently in data centers we do face this problem where we're trying to use GRE, and we are running into cases where we're not getting ECMP, so we're getting imbalances, path imbalances. So just as a drop-in replacement for GRE and nothing else, this actually has merit. This does not solve all encapsulation issues, and certainly for NVO3, NVO-GRE, which would be the closest thing, really probably isn't sufficient in a lot of cases, so we will have other encapsulations. But you are correct, in the end of the day, this could actually be encapsulated in something else, and I think this goes back to the layered encapsulation approach.
Yeah. Okay. And one other thing, one reason to use something inside UDP is so you can go across NATs. And that might be a use case that we want to use something like this for, out in the public internet, for example.
Could be, but again, we have to consider the ramifications of things like congestion control and what have you. So I don't think there's any restrictions, and certainly people will be using this on the public internet. We're not going to stop that. And again, because it's UDP now, it's actually more likely that this can pass through a lot more devices. So we know we're enabling this capability.
Okay.
Ramifications, we'll see.
Okay, thanks.
Okay, so this brings us to the famous IP UDP 0 checksums. And so everybody should be aware, the fundamental issue here is that IPv6 does not have a header checksum, unlike IPv4. So if we turn on a 0 checksum in IPv6, there's essentially no protection for either the IPv6 addresses or the UDP ports or the UDP payload. So the easiest answer here is use the UDP checksum, or make sure you have a link checksum. And this is kind of problematic, especially in certain devices that don't support a payload checksum. So what happened was RC, I think it's 6935, 6936, basically were defined on how to use zero checksum with UDP for IPv6. So these RCs need to be quantified in a sense for each encapsulation. So in the case of GR over UDP, what we want to make clear is that the IPv6 zero checksum makes sense under certain conditions. In particular, a single administration where we know that corruption is exceedingly unlikely, or we can measure that it's exceedingly unlikely, then it becomes a good candidate for a zero IPv6 checksum. Or alternatively, if we already know that anything above the encapsulation in the application is tolerant of this sort of corruption, which may very well be the case in a kind of closed data center, then it's kind of acceptable in that case. Next slide.
Is that list meant to be an OR list or an AND list?
Or.
Oh, then I have problems, but I'll come to those later.
It's an OR list in addition to the first two, I'm pretty sure, at least in the MPLS draft, extended to multiple cooperating administrative domains.
So I think we're calling it an OR with a must for at least one of those.
Yes, you have to have one of them.
So we actually came up with a number of specific requirements to meet 6935 and 6936. So UDP checksum must be enabled by default for IPv6. And we have a couple of mitigations to attempt to either use different addresses or different ports for IPv6 traffic where we're using the zero checksum. The part G was that IPv6 traffic with zero checksums needs to be monitored at some level to make sure we're not getting corruption. So we're not just losing the ability to check the IP addresses and UDP ports, we're also losing the packet checksum. So that's one thing we can actually monitor in kind of out of band. There was a part C to this that we aren't going to adopt, that will probably be removed, was the idea of using different destination ports for the different use of checksum, and it turned out that's not as practical as it is in MPLS. Next slide. Security. So GRE UDP does not secure the payload, neither does GRE, so in some sense we're not losing anything there. There is an alternative, since this is now UDP, to use DTLS as an application layer security. There are also, separate from security, and I think this was discussed a little bit in the encapsulation design, we also need to worry about the security of the headers themselves, both the GRE header and the UDP header. This became kind of an issue, particularly in NVGRE, where we have virtual network identifier that's very sensitive to either corruption or spoofing. So one of the recourses there would actually be to use GRE checksum, which would at least perform some check against corruption of that field. So in some sense, in certain cases, we may recommend use of GRE checksum if the GRE header is actually sensitive to like misdelivery because of corruption. Next slide. UDP source port. So I believe this pretty much follows what most UDP encapsulations are going to be doing. We'll use that as an entropy value, either 14 bits if it's an ephemeral port, 16 bits maximum amount. Should also be mentioned that the source port can change over the lifetime of a flow, which might help if we need to rebalance ECMP. There was one addition: if we cannot derive this value out of a packet, it's still quite important to set it to something. And we want to make sure that that something is kind of consistent so that flows aren't reordered. So the idea was to use a randomly selected value for the system and assign that on a kind of a consistent basis, at least for the outer IP headers, addresses. Next slide. There were some other miscellaneous editing changes. So we simplified the title a little bit. The sections have been reordered, hopefully have a better flow. We refer to 540 bis. The applicability statement has been modified a little bit. We also added quite a bit of text about the UDP checksum in IPv4. This is also important. We look at IPv6 UDP 0 checksums a lot because of the capability of misdelivery to an IP address. It turns out that even in IPv4, corruption of a port can result in misdelivery to a port. So there is kind of another problem in that area that's applicable to both IPv6 and IPv4. And then we added myself as an author and Gori as a contributor. Next slide. So any additional comments, feedback, technical concerns? And I think David mentioned the plan is to get to last call middle of this year, hopefully at ISG in December.
Martin Kimmerling speaking as an individual. If you go back like 2 slides where the selection of ports, the source port, I think that goes back what we had in the MPLS over UDP document. That you need to add some, at least information for people implementing and deploying this, that you're not expecting traffic coming back on the same tuple of port numbers. Also, like, if you have ICMP messages coming back, there's nobody listening to those things.
So that does expose us to the ICMP problem.
Yeah.
And what Martin said is correct. There's if you haven't already copied it over, there's text in MPLS UDP draft you can copy.
Yeah. And also there's something about like configuration of NATs in between, because you never see traffic coming back on that port. But you need to, if you have reverse traffic, you have to configure the reverse path on the NAT, for instance.
Yeah.
It's a very interesting question how to solve that.
But
Static config.
you know about it. It's an
Static
MPLS
config.
there's some text about it already.
Unfortunately. Yeah.
There is one potential mitigation, and I know Eric doesn't particularly like this. In IPv6, technically we could use the flow label to provide ECMP through the network. The concern there was it's probably not deployed. But had we had flow label deployed, we could use that as a 20-bit entropy field, larger than what we get out of the UDP source port. And then presumably we could set the source port and destination port to the encapsulation port and eliminate the ICMP.
And I'm going to exercise an override as working group chair and send that rat hole to the bar, please, so we can get on with get on with the next presentation. Is that possible?
Oh.
I tried.
I have more comments.
Okay.
Email.
Yeah, I think.
So Eric, not Mark, I think commenting on what the part I didn't like was the notion that, as we discussed things in the design team, was you could potentially have a different set of headers if you use the flow label with V6, because you said, well, I don't need a UDP header if all I use the UDP header is for entropy, right?
Yeah.
And that's different than saying the header is there, but it has a fixed source port, right? I think that particularly if you look at implementation considerations, saying I have the same header pattern, I just have a different way of assigning the source port value. I think that's easier from an implementation perspective. And as long as your entropy calculation says I'm taking into account the UDP source port, the flow label, the source destination IPv6 addresses, you get the desired behavior. Right?
Okay.
Because it happens to be.
And if you want to continue this discussion, routing area working group, please. Nurit, you're going to do the honors here. Okay. Let's see.
Hi, is this loud enough? Perfect. So my name is Ankur Jain. I am actually presenting instead of Andreas Thursas, who's been driving this work
from our team, and he was unfortunately not able to join at this IETF because of a surgery in their family. But I still hope to do a good, at least a decent job of trying to present the work. So the last 2 days there have been lots of these discussions around the, how should I say, the relationship between middle boxes and content providers. And being from the content delivery space, to be honest, I share some of those, I've shared those concerns for a long time. But what we wanted to do in this presentation was highlight one of those use cases where we think that end-to-end delivery can indeed be improved based on certain information that you can get from middle boxes. The first draft over here, it talks about, it focuses on the use case and the set of architectural requirements that we envision would govern a mechanism to support the transfer of that information from the network or from the network part to the app. And to make sure that we are talking about a sort of grounded use case, we end up implementing a fairly simple proof of concept that adheres to some of those architectural principles, but may not necessarily be something that we all agree with. But we use that to run experiments on a real LTE network. And Swami, who is over here with me, will be talking about very briefly. Will be talking about the proof of concept and the results from that experiment. But really, the focus we want to keep the focus of the discussion today on the use case and more pertinently the set of architectural requirements that we envision for this exchange of information. Next slide. So I might be preaching to the choir, or at least part of the choir over here, which is as on a cellular network, there is the radio link to an end user ends up getting changes at a fairly rapid pace, and that could be for all sorts of reasons, including mobility of the end user itself, or for that matter, other users who are entering or exiting the network. TCP is not necessarily able to adapt itself as quickly as, say, it would be able to in a more static environment like a wireline network. And this, at least in most cellular networks that we have studied, where the final radio link ends up being the congestion ends up being the bottleneck resource. This inability of fully utilizing the radio resources ends up wasting precious radio resources, which can partly be solved by having larger buffers at some of the middle boxes, but all in all, that these together end up resulting in suboptimal user experience.
Just very quickly, can you hold the mic up a little bit?
Sure.
I have trouble hearing you again.
Is this better?
Yes, much better. Thank you.
Next slide. So the key insight that we are using in the solution that we are proposing is that there is a middle box in the network, namely the base station, which in a cellular network has a fairly accurate idea of the available capacity at the last hop to the end user. And if there is some way that we can provide this information to the server, to let's say the TCP server, we can it can use that as a hint to in different ways. It could use this as one of the signals that it uses in its congestion control algorithm, or it could be one of the signals that it could use that in the selection of the initial congestion window and other transport variables. But at the same time, this is an information that can be exposed at the application layer also. And for, let's say, an application like video streaming, that could result in more optimal choice of the bitrate for the video. Next slide. So the last two slides were mostly focused on trying to identify the use case that we are targeting. The next couple of slides will be focused on what we envision the architecture building blocks as well as the requirements as we see them for those. So at a very high level, there is some sort of a box called that we are calling a throughput guidance provider, which exists somewhere in the radio access network and has a fairly some magic is able to figure out what is the available bandwidth to the end client at the last stop, and it provides this information back to the TCP server, which then use this information in some magical way to figure out the rate at which it should be sending packets to the TCP client. There is these first 2 points are what I'll be addressing in more detail in the next slide. And then finally, we want to establish, we think that we need a trustful relationship that needs to be established between the server as well as the TG provider for a variety of different reasons, which I'll cover in the slide after that. I was thinking of taking questions towards the end, if that's, if that's okay.
I'll just stand here then.
Okay. That's how it works.
Next slide. So for the vast bulk of traffic that we were right now considering in the scope of this discussion, it was TCP traffic as well as the specific use cases that we were looking at. We are seeing more and more of traffic moving over to HTTPS. So whatever be the mechanism should end up working with these protocols. The radio downlink, the radio downlink the capacity on that ends up varying at a fairly dynamic rate, and so we would like to make sure that the guidance that is getting provided to the TCP server ends up happening at nearly the same time granularity. Finally, we'd like to make sure that I like to emphasize that we are not we do not think that this should bypass congestion control algorithms, but rather this is just another input in that can be used on the server side. On the security side, I think there are a few key things that we want to highlight. One is from a network perspective, this is considered to be a confidential piece of information, and therefore there is at least a desire from many of the from the network providers around keeping this information confidential. From the content provider perspective, we'd like to make sure that there is we have the ability to authenticate the identity of the TG provider, and mostly to ensure that the integrity of the information that is getting sent from the TG provider up to the TCP server. Next slide. All right. So actually, at this point in time, the first couple of slides were focused on the use case. Then, at least some salient requirements that we had highlighted out for the mechanism to transfer this piece of information to the TCP server side. And I'll now hand it over to Swami to talk about a particular proof of concept that we used to gather some results around this.
Thanks, Ankur. I'm Swaminathan from Nokia Networks. Okay, so this is basically, we started working with the requirements, and then we started realizing with the Strawman architecture. So this is maybe one way of implementing the requirement, but this is not the only way of implementing. So we have taken the TCP in-band signaling in order to pass the information from the network towards the TCP server. So why we have taken in order to look at it? Basically, it's a general solution where it was also working with HTTPS. We didn't go with any application level information transfer. Instead, we went it on the TCP level, and then it's also application agnostic, and then it doesn't require a separate interface. So if in case we go for an out of band, we need some correlative mechanism in order to correlate the specific information for that particular flow or for that particular user flow. That we, in order to avoid that, we went for the in-band signaling. This was the reasoning why we went for the TCP in-band. And then the TCP server, which was on the other side, basically, as Ankur was mentioning, we were taking a direct implementation of, we have used the throughput guidance in order to arrive at the initial window, and then also changing the window sizing whenever the radio conditions are changing. And then when also during the congestion avoidance phase, we were using the throughput guidance as a hint. So not directly taking it, but it is using as a hint as a part of the already existing congestion algorithm. And then upon the loss, actually if you see, we were able to give only the throughput or the bandwidth which is only on the radio link, not anything on the backhaul or not anything on the towards the internet. So it was only on the radio link. So whenever we see the losses, the server will revert back to the standard TCP because maybe the congestion may be on the backhaul or is still behind that. So in those cases, it will be falling back to the normal TCP and then it will be starting working. So this is basically from an architecture realization of the architecture, whatever Ankur was explaining. Next slide. So these are the results which we were able to see. So this was on the real network. It's on the LTE live network. So we have deployed it in 5 eNode Bs, and then the real users were there, and then we had some 4 to 5 test users with the test users of a different environment when the cell is completely loaded, and then if the cell is not loaded. So different scenarios we have taken into consideration, and then these are the results where we have seen. So we have split it into 2 levels of metrics. One is on the network, and the network is more on a TCP based, and then application level is more, as we have taken YouTube as an application, this was more to do with the video delivery application KPIs. So let me get on to the network API. So we were able to see the improvements on TCP round trip time and then TCP packet loss. These were mainly because we were able to reduce we were seamlessly taking the TCP with the bandwidth availability. So as we were taking it like that, so we were able to see the round trip time is also reducing, and then also the packet loss were reducing. If you see the mean client throughput were also really improving. And then
John?
Okay, so quickly on the...
We have about 1 minute left, so...
Yeah, quickly on the application level, if you see the click to time and then average video resolution and then also the video format changes were really improving. These were mainly due to the network APIs, whatever we were looking at.
Mm-hmm.
Yep. Thank you, and then we are open for that.
Okay, let's open the mic for questions.
Okay, Fred Baker, random router. And I'm just going to prove that I'm a real IETF participant. I have not read your draft, but I have a comment on it. And or a question. And my question is, I wonder if you've looked at RCP or XCP and what the experience was with those technologies. They were attempts to do approximately what you're trying to do, which is to set C1 to the right number. So did you look at them?
Okay, so basically we were more looking from the YouTube point of view, which it was using the HTTP, and then the algorithm what they were using is not the protocol, which is already whatever you are mentioning. So that's why we went and then tried with the HTTP, and then it was more to do with the YouTube current algorithm.
RCP is a signaling mechanism to tell you the rate to send it, yeah? Okay, Bob?
Yeah, Bob Briscoe, BT. Yeah, this is an important problem to try and solve. However, it worries me that you're trying to solve it without even knowing about RCP, and more importantly, or XCP, more importantly, there's now quite a lot of theory around the stability proofs of a network like the internet based on protocols like TCP or dually based on XCP, RCP. And if you do something like this in isolation, and you say, yes, if there's loss, say, on the backhaul, you can detect that and fall back to TCP, but the point is, in the process, you may have caused a huge amount of loss by accelerating fast, because the radio network says you can, but it doesn't know about the backhaul network and how much you could have caused. So a whole network has to work like this, not just part. And if you don't know about the stability proofs, you're in very dangerous territory. I mean, we're trying to solve this problem. We're trying to solve this problem, but you've got to be very much aware of what you're playing with. You know.
Yeah, I completely agree with you. So what we have planned is, as step one, we were looking into the radio, and then step two is more towards the other side. So why we went for the step one to be radio, when we were generally looking into the deployments which is already there, the radio is what the bottleneck we have seen in most of the cases, as we have seen now. So that's why we have taken at the step one
that's what I'm saying. I'm saying step one is the network, step two is the radio. If you don't solve the network problem, you stop. And no one is going to take what you do.
Okay, next call.
Hi, Aaron Falk. First thing I want to point out is in around 2001, the IETF chartered a working group called PILC, which was Performance Implications of Link Characteristics. It was to respond to concerns of primarily people related to wireless networks, to address exactly the problem statement that you have, which is wireless capacity is a valuable resource. How do we get better performance over it? I strongly suggest that you take a look at the documents that came out then. I think that you'll find it relevant to what you're trying to do. Second, I ran a group that implemented XCP in the kernel 9 years ago now. One of the big challenges that we ran into is once you identify your bottleneck link, so let's hypothetically assume that your wireless link is your bottleneck link. When you have more than one flow, identifying how many flows that you have, how you divide up the capacity and share it equally or fairly among them. So I want to agree with everything that Bob said, that making the beginning of your connection much more aggressive is going to degrade a lot of other people's experience in shared resources that may not be bottlenecks today, but you may be creating bottlenecks by causing the connections to be more aggressive. There's a reason why slow start starts slow.
Next, we have limited time, but I'd like to get through all the lines. So
I'll be quick. It's a comment. Kevin Smith from Vodafone. So my name's on there as well. So the reason we got involved, I think, is a decent motive, which is that we want to be able to tune the flow for the user experience on the fly, but without breaching encryption in any way, shape or form. And we see this as being, as Swami was saying, a first step towards doing this. But we thoroughly take on board all the comments about pre-existing work. And we'd welcome comments onto the mailing list from people on things that we've missed so far. So.
Maybe I can just ask a quick question. I mean, do you see this as a general principle that this should go into all TCP stacks to do this, or do you see it as something that's operator network specific?
Well, we started off with looking at radio, so obviously that's our bread and butter. But no, that's a broader question for the group, I'd say.
Sure. Thank you. David?
David Black speaking as an individual, not as working group chair. Want to sort of first one I've got to make reinforces something both Bob and Aaron said, which is that your bandwidth management problem is asymmetric. Decreases, sure. Tell TCP to shut up, no problem. Corresponding increase, tell it to start yelling again. Well, things might change since you told it to shut up. So the problem is asymmetric, and just because you told it to shut up doesn't mean you're allowed to tell it to quick go back to where it was. Keep that in mind. want to suggest that there's another requirement lurking in security, which you seem to have focused on the security properties of the communication, and I think you should also focus on the participants. Who all would be allowed to use this? At what scale does this mechanism need to run? What are the entities of the folks involved? And how do I sign up to use it for something I just want to do off this little server over here? Take this input. I just think about security, and then finally, I'm going to do a favor for some of the folks around here. This use case that you're talking about here will also be discussed, but in the context of a very different protocol stack. Tomorrow morning in the Spud or Spood bath, depending on whether you adopt the English or German pronunciation.
A specific general set of responses and comment, and I have one higher order comment as well. First, I think that there is, I completely agree with speakers behind, Bob and David said. There are specific situations which this particular solution seems to be targeting, and I think that generalizing this is going to be very useful, and to that extent I think that the requirements part of this presentation is extremely important for us to consider. And I'm going to say that this is coming up again and again at the IETF. As David just said, we are going to have exactly the same set of requirements, or roughly the same set of requirements again tomorrow. So it's kind of important for us to actually consider this set of requirements. And my higher order comment is, my soapbox is that this is all happening here because TCP congestion control blows. And it's so we're trying to fix problems that we should have fixed. And this is a hard problem. I mean, we have problems of deployability, we have problems of trying to get protocols out there that actually work on the network and utilize networks well. And these are problems that operators are obviously facing on the ground today. And if we don't have a good systematic solution to this particular problem, we are going to keep handling hacks.
Hi, my name is Michael Scharf. As a random contributor here, I just want to point out there's an RFC 677, which is an IETF RFC, which is a pretty long discussion about network supported congestion control, which was basically written as an outcome of the experiences Quick Start, RCP, and XCP. And that RFC contains a lot of discussions that you might want to address here, and what I would love to see is how you want to solve the challenges that are in there. That RFC enumerates quite a number of challenges. They might be solvable in that specific context, but I would like to see this because this is one of the best write-ups. What is really to be done if you want to make this work? So look at that RFC and please. Which number? 677. 677? No, 677. Challenges?
6077. So I'd just like to I'd just like to mention one thing, that I really appreciate all these comments coming in, and I fully agree that that there is background literature over here where people have tried solving exactly the same set of problems, and we should absolutely take a look at those. The main focus, the main thing that we wanted to focus on, exactly as actually Jenna mentioned earlier, is that there are many other forums in which the same set of problems are getting discussed, whether it's Spud or tomorrow.
Sure. I mean, we presented this here so we can see the problem space. We're not criticizing this particular thing, but we're trying to indicate how to proceed afterwards. But we are running out of time, and I really do want to let everyone talk, so short question, short comment.
10 seconds. I did say, I was very critical, but I did want to say that that there may be some utility in telling the application something about the minimum capacity or the maximum capacity that can expect. So you don't choose an encoding rate that's beyond what the wireless network can support. But that sort of falls into the range of hints.
Jonathan, you have 10 seconds.
A very quick comment. While fairness is something that's useful to chase, because as pointed out earlier, the current state of the art is fantastic in that anything is better than the current state of the art in terms of fairness.
You're magnitude agree.
Mr. Dawkins, the responsible area director for SPUD, among other things. I'll do this just real quickly. My suggestion would be that you and all your friends attack fairly violently, but not physically, the area directors who will be at the TSV area meeting on Friday. Is that right, Martin? And make them bash the agenda to talk about this at least for a little bit. When I was, and Aaron mentioned, the other one was TrigTran, which was a ball I co-chaired both times. The area director was told as feedback that she should have been recalled for approving the BOF, and I should have been arrested for proposing it. So this has been controversial for a very long time, and it would be great for me to make any progress at all besides going, TCB congestion sucks, which, yeah, we know, so next. But like I say, so I would encourage, Martin and I do say no to BOF requests, but we've said yes to a hell of a lot more of them than we've said no to. And you can...
I hear you, but I think we're hint. I think that has a hint. I'm going to cut the line. I'm sorry, Bob, but we're out of time. And my pushback on this is we have a proposal for some performance improving algorithm related to TCP. We haven't seen data on the algorithms. We haven't seen how you can realize such a thing, and given the track record we've seen in the algorithms world, I think we should be encouraged to come and bring solutions and traces, etc., to the IETF, ICCRG, where we talk about congestion control. Sort the congestion control bit out, give us suggestions about how the congestion control can be improved, and then we can come back and talk about the architecture side. That's the TSV pushback. By all means, speak to the ADs as well.
Yeah, and all I wanted to say was that SPUD is only part of the solution once you've solved the congestion control problem.
Mira, you can have 2 seconds.
Yeah, I have the last word as one of the SPUD chairs, so I just want to say that at least the use case you have is definitely interesting for us, so you should come and talk to us. And it's a non-working group forming BOF, so we really try to collect those use cases and make sure that we are aware of everything that's out there.
Okay, thank you everybody. Please come along to the next TSVWG session, but have a great time until then.
I was going to go to
Well, the next one's all protocol stuff, isn't it? So that's all right.
Well, down here we have to figure out what tunnel congestion feedback is.
Oh yeah, we do. We haven't talked about that. We should talk sometime about that. Yeah, we can do that. All right. What's your ID now? 17 and 13. No, I should be here doing AQL.